Hello, welcome back to the online course on analog integrated circuits. In our previous class, we have talked about one of the most important integrated circuit, IC555, and I mentioned some of the applications of IC555. In today's lecture, we are going to discuss one of the application which is Astable multivibrator. Let's look at what are the questions comes in the previous year examination from this topic. There is only one question asked so far from this topic, which is explain the working of a stable multivibrator. There are many other questions we can expect from this topic that we will discuss later. A stable multivibrator or free-running multivibrator is a rectangular wave generating circuit. We call it as a free-running multivibrator because this circuit does not require any external trigger to change the state of the output. And a stable multivibrator can be produced by adding two resistors and a capacitor to the basic timer IC as shown here. The output have two states, either high or low. The duration of each state depends on the values of externally connected resistance and capacitance. Here, pin 1 is grounded and pin 4 and 8 are shorted and connected to the VCC, the DC power supply. Also, the output is taken from this pin 3 and pin 2 and 6 are shorted, then connected to the ground through capacitor C. There is a resistance here RA between pin 7 and VCC, and RB is connected between pin 6 and 7. Here there is a capacitor, you can see C1 is connected between pin 5 and ground, which is known as bypass capacitor. It prevents noise coupling onto this pin. Here is the Astable multivibrator with the internal circuit of IC555. In the given circuit, I just ignored two elements. One is reset pin and the transistor connected to this pin, and the power amplifier which invert the flip-flop output is replaced with taking Q bar as the output, and both are functionally same. Let's recapitulate some of the key points from the previous lecture. The output of IC555 is mainly depending on pin 6, which is threshold input, and the pin 2, which is trigger input. The voltage at the P is 2 VCC by 3 and the Q is VCC by 3. Also, threshold is comparing with this VP and trigger is comparing with VQ. For getting low output, the voltage at the threshold must be greater than 2 VCC by 3, and for getting high output, voltage at the trigger input must be less than VCC by 3. These are the two key points we should remember to understand the working of a stable multivibrator. Let's move on to the working of a stable multivibrator. Suppose when Q is low, the output is high, the discharge transistor is in cutoff, hence the capacitor C begins charging towards VCC through this RA and RB. So the timing constant during this charging is RA plus RB into C, and the rate of charging or the speed of charging depends on this time constant. Here we can see this capacitor is connected to the threshold and the trigger input. As the capacitor charges, the threshold voltage also increases. Eventually, at some point, the threshold voltage exceeds 2 by 3 VCC. When the threshold voltage exceeds 2 by 3 VCC, the first comparator will produce high output and it set the flip-flop so that its output Q become high and the timer output is low or 0. The high output from the flip-flop saturates the discharge transistor so that capacitor starts discharging through RB and the transistor with a time constant RB into C. With the discharging of capacitor, trigger voltage at the comparator decreases, and when it drops below VCC by 3, the output of comparator 2 goes high. And this resets the flip-flop so that Q becomes low and the timer output becomes high. As the Q is low, the discharge transistor turns off again and the cycle repeats. This is how the auto transition occurs in the output from low to high and then to low. Let's look at the waveforms. The first waveform represents the output and the second one represents the capacitor voltage. The time during which the capacitor C charges from 1 by 3 VCC to 2 by 3 VCC is equal to the time duration the output is high. And this time depends on the time constant τ1, which is equal to RA plus RB into C. On the other hand, the time during which the capacitor discharges from 2 by 3 VCC to 1 by 3 VCC is equal to the time duration the output is low. And the time period of this oscillating wave is equal to the sum of T high and T low. And the frequency of oscillation equal to the reciprocal of the time period capital T. Let me stop here today. We will discuss the derivation of time period and frequency of oscillation in the next class. Okay, thank you.